think is open? Well, the first point I'd make is your current licensing system is probably crystal clear as it stands. Most companies will be running a number of software systems. Those software systems will have different licensing. You may have a site license for some of your software. You may have a per CPU license for other software. You may have a number of concurrent users licensed for your other software. Software licensing is already tricky. But the licensing system in the open source world, although there are a variety of licenses out there, the licenses that we have to worry about, and I don't think we do need to worry about them, are really designed to make sure that open source does not become closed source. So most of the licenses say, if you change the source code and modify the source code, you should release that source code back. So you can't grab an open source project and make it closed. And it's designed to try and prevent that. It's designed to try and promote sort of the idea of free speech in software. If you don't modify source code, if you're not interested in modifying source code and you're just interested in implementing an existing system, as most of us are, then it doesn't make very much difference at all. In fact, it may make life a lot more simpler because you're not going to get into trouble for not meeting your licensing requirements, because effectively you can have it installed wherever you want. I'm exposing the company to more risk. By introducing an open source project, are we inherently introducing risk into our system? Are we having a chance of a failure of a system more likely, or is the system risky in some other way? As I said before, open source projects, you still have to be careful about which ones you choose. You want to look for the ones that have reached a level of maturity and stability that you can pretty much rely on them. There are, I don't know whether any of you browse SourceForge. SourceForge is a website which has hundreds of open source projects. I would say about 70% of them aren't active. So if someone starts something off, there's a big impetus to start something, but for various reasons it doesn't get the ball rolling and it doesn't get enough momentum to start moving forward. So you have to play it safe. You have to look and see what's available, what's been around for a while, what has a core development team built around it, what's being utilised out there, what have other people picked up. These are generally going to be much less risky. Will it work with my other systems? This is where we hit a really big tick. This is where open source is top of the heap, if you like. Open source, and particularly open source for Geo, lives and dies by standards. Its whole raison d'etre requires communication. Open source projects tend to be a single application. So there is a development team developing an open source spatial database called PostGIS. There is another team developing a desktop system, which is quite popular, a GIS system called Quantum GIS. I'm sure we'll be introduced to these over the course of the day. What you don't get with open source development is people developing a vertical application chain that goes from mobile to desktop to server and all of the products in between. In order for their system to be used, it must communicate with other systems. Many of you will be aware of the Open Geospatial Consortium in the GI world. The Open Geospatial Consortium is a group of 500 companies, institutions, universities and individuals who come together to define standards for geo. And many of these standards then get adopted by the International Standards Organization and integrated into our systems. All of the OGC standards have their reference implementations, so the standard for the standard, if you like, based in open source software. Standards is where we really win. And as the world moves forward and we're required to share our data, either whether it's through the EU Inspire directive or other government policies to release more of our data into the public domain, standards are going to play an increasing part. Will the software be around in 5 years? Well, the honest answer is, of course, we don't know. Many of these projects have been around for more than 5 years. One or two of them are a bit newer. There are new developments coming through all the time. You have to play a little bit of a waiting game and see who's actually developing it and see how it's around. But 5 years is a long time to wait. 5 years ago, there was no YouTube, there was no Facebook, there was no Twitter, there was no iPhone. 5 years is a long time in the industry. So we don't know, but you have to consider these things when deciding whether to move towards your open source products. Many of our products have been around for a very long time. I used to work, many years ago, I worked at IT in Nissan, and in the design department in Nissan. And one of the things, I was young and still wet, of course I'm still young now, I was younger and still wet behind the ears. And I didn't really know a huge amount. I blagged my way through most of it whilst I was there. What I really liked was this guy called Carl, who worked for the people who implemented our network, who I could ring up when I got stuck. I really liked Carl because whenever I couldn't solve a problem, he always could. And for various reasons, he was interested in maintaining a contract with Nissan, so would always come out and fix things if he was driving past. And I think many of us are in this position on a daily basis. What we don't want is to be the last line of defence. And there's a lot of reticence about taking away that crutch of having a number you can ring and someone going to answer it because you've got a problem, your boss is shouting at you, and you need a resolution to that problem. And it's a valid point. However, these days there are a huge number of companies, both in the geo world and the non-geo world, who provide exactly the same sort of maintenance and support agreements that you currently have with your commercial software. The only difference, there is no difference between that and the contract you will have with whoever it is, with Microsoft or ESRI or whoever provides your support contract. Of course, you're still going to have to pay for that support and maintenance. The other thing to bear in mind with support is the development teams, the way these projects have come about, they're developed in a distributed fashion. The internet is everything with open source, because you may have a developer in Australia communicating with another developer in California who's communicating with another developer in the UK. We can only do that through the internet. So there's a vast amount of resource out there that's based around distributed systems. The other thing about support is sometimes it pays to be able to communicate much more directly. If you have a problem with a piece of open source software and you find a bug, for instance, you might want to report that bug. Now, I don't know whether you've ever gone through the reporting process of a bug to somebody like Microsoft or ESRI or AutoCAD or anything like this, but it's a long-winded process. You may ring up your customer services rep, or there's a website to fill in, and chances are you'll never hear anything of it again. With many open source projects, because the developers effectively are looking at these bug reports on a daily basis, and there's a small core development team, often these things will get fixed much more quickly. It'll be fixed, it'll be patched, and there'll be a new version released. We've certainly seen it when we've reported bugs within 24 hours. So you're getting a new fixed version of the software within 24 hours, and almost direct communication with the guys developing and writing the software at the coalface. One of the worries people have with open source is, I'd like to dip my toe in. I don't want to throw everything away that I've currently got. I've got lots of systems. One of the benefits of open source, as I've already said, is this real reliance on standards and integration. Integration is at the heart of open source, and particularly at the heart of open source Geo. So do you have to replace it all? Absolutely not. You can pick and choose components that slot in to wherever it suits you in your organisation. So maybe you want to replace something in the back office. You want a new database system. ArcGIS 10, for instance, now supports PostGIS, which is the leading open source spatial database, as the back end to its SDE implementation. So you don't need SQL Server or Oracle in the back end. You can have PostGIS, which is based on the Postgres product. Likewise, MapInfo now does direct read-write into a PostGIS database. So you could change your back end. Or maybe you're reliant on a commercial piece of software to provide your web mapping tool, your API that you provide your data via an intranet or an internet. Well, again, you could pick an open source replacement for that component. What we have in Geo, in open source, and it's replicated in commercial systems, you can go and find all of these tools in commercial systems, is the vertical application stack, if you like. So we start off at the bottom. We start off with our data systems. We may have some spatial databases. And at the other end, we've got desktops, desktop clients that work like your standard GIS, your MapInfo, your ArcMap, and the like. We may also want to display our data using a web front end, and there are a variety of open source solutions. As you might expect, the web and that area is one of the thriving points of development. So there are a number of things. Mobile, we're starting to see things move into mobile apps as well. On top of our data, we have products that take information out of databases and squirt it out in other ways. So just like Google Maps takes data out of the Google databases and puts it on the web, we have open source implementations that do just this. They're map servers. And they're all standards compliant. These are OGC standards for web map services, web feature service, web coverage service. And these are the reference implementations for these standards. So if you want to be standards compliant, you know you're standards compliant when you're using these products. And then there are specialist bits that make everything work together. Separate little developments. We all these days must make sure our maps load quickly on the internet because we have Google to compete with. We don't have the resources of Google, but there's plenty of products out there. There's tile map servers, Geo Web Cache and the like, which allow us to produce maps that work as quickly as Google Maps, which is what our customers expect. So hopefully during the course of today, you'll be introduced to some of these products and how people have used them to solve real-world problems in production environments. I'm going to hand over to John from the Ordnance Survey, who's going to tell us a little bit about open data and open space.